Type 4 words, a cat in a wizard hat, and a picture of exactly that appears. A cat, a hat, pure wizard. And the whole family goes, "Whoa, the AI can paint." But nobody claps for the weird part. Before it painted a single pixel, the machine had to understand that the word cat and a picture of a cat are the same idea. That is the real magic trick. Today, we expose it. This is AI Papers for Humans. One landmark paper turned into a bedtime story a parent and a kid can both enjoy. The series has been one long story. Machines learning to see, to read, to think, to dream. But a secret wall ran right down the middle of it. Today, we knock it down. Remember episode 6, AlexNet, the day computers learned to see? It studied 1 million photos, each sorted into exactly 1,000 labeled boxes. Dog, cat, school bus. Brilliant, but trapped. Show it something outside those 1,000 boxes. An avocado chair, your kid's drawing of a dragon, and it freezes. No box to put it in. It only knows the labels we handed it. That's the wall. On one side, machines that see pixels. On the other, machines that read words. And the two could never talk. So, in 2021, a team at OpenAI asked a beautifully simple question. What if we stop handing out labeled boxes and just play a matching game? You know the game. Flashcards with words, a pile of pictures, and you draw the lines. This word goes with that picture. That's the whole idea. It's called Clip. And the one thing Clip does, 400 million times, is match the caption to the photo. Where do you find 400 million pictures that already come with the right caption? You don't. The internet already did. Every product photo with its description, every meme with its text, every vacation pic, captioned, sunset, finally relaxing. The whole web is one giant pre-labeled deck. The paper calls it natural language supervision. The caption that came with the picture is the label. Same move. Whisper pulled in episode 11. Don't sip a tiny clean dataset. Drink the whole messy ocean. Here's how the game runs inside. Grab a batch, a handful of images, and then real captions. Images down the side, captions across the top. A grid. N images, N captions. N times N squares, every possible pairing. But only N are true matches. The diagonal, where picture 3 meets EES caption 3. Everything else is wrong. Clip's whole job. Light up the diagonal, darken the rest. And lighting that diagonal is the beating heart of the paper. Picture an empty room where every image and every sentence drops in as a single glowing dot. Real match? Training tugs the two dots together. Wrong pair? It shoves them apart. Do that 400 million times, and the room organizes itself. A puppy photo, and the words, a photo of a puppy, drift to almost the same spot. Pictures and words, at last, in one shared space. Now, you'd think the smarter move is to make the I write the caption. Generate the words. The team tried that first. It learned about 3 times slower, because writing the exact caption, a fluffy golden retriever on green grass, slightly out of focus, is brutal. 1,000 right ways to say it, and it has to nail one. Just picking the match from a lineup, far easier. You don't produce the words, you only recognize them. So, don't predict, match. So Clip is two brains working as a pair. One reads the picture, the image encoder. The other reads the words. Built on the same attention engine from episode 5, the spotlight behind every language AI. Each brain boils its input down to a vector, a long list of numbers, which is really an address inside the shared room. Train them together and they agree. A dog photo and a photo of a dog point to the exact same address. And here's where it gets spooky. I show Clip a photo it's never seen and ask it to sort that photo into categories nobody trained it on. How? Not boxes, sentences. A photo of a cat, a photo of a dog, a photo of a corgi. Each sentence becomes a dot. The photo becomes a dot. Clip asks one question. Which sentence dot sits closest? Whichever wins is the answer. No training examples. The paper calls it zero shot, and it means Clip recognizes almost anything you can put into words. Okay, parents, here's the number that knocked researchers off their chairs. Plain zero-shot Clip. Never trained on ImageNet, that 1,000-category exam from the AlexNet episode scored 76.2%. Now set it next to ResNet 50, a respected model that DID trained on all 1.28 million hand-labeled photos. It scores about the same. A model that never saw a single training photo tied one that memorized over 1 million. The hand labeling, it turned out, was optional, and it wasn't a one-test wonder. They turned Clip loose, zero shot, on more than 24 completely different challenges. Naming flower species, telling car models apart, reading house numbers, classifying satellite photos of land. One model, zero retraining. And on most, it held its own against models built and drilled for that single job. Not a dog detector. Not a flower detector. The first vision model that was kind of good at everything you could name. But the deepest result isn't any single score. It's what happens when the world gets weird. Take an ordinary ImageNet model and show it the same objects as cartoons, sketches, blurry versions. It falls apart, sometimes from 70-something% down to 30 or 40. It memorized the look of its photos, not the idea of the thing. Clip barely flinches, because it learned dog from the whole messy internet. Clip art dogs, statue dogs, cartoon dogs. A sketch of a dog is still a dog. Real understanding is what survives when the picture changes. And now the reveal this series has been hiding. Episode 9, Stable Diffusion, and Episode 12, Sora. You watched AI dream pictures and whole movies out of static, steered by your words. We showed you the painting. We never told you what held the paintbrush. It was this. When you type a cat in a wizard hat, the thing that understands your words and aims them at the pixels is a shared word. And picture space, clips, or a close cousin. We built 2 whole episodes standing on this bridge before we showed you the bridge. Now let's keep it honest, because the paper does. Please. Clip is lopsided. Ask it, how many cars are in this photo? And it gets shaky. Counting and careful step-by-step tasks aren't its strength. It's fussy about wording too. A photo of a thing works noticeably better than just thing. People literally tune the sentence. They call it prompt engineering. And swallowing the unfiltered internet means it swallowed the internet's biases. The authors test for that and warn about it out loud. A machine that learns from all of us learns the worst of us, too. So step back and look at what really happened in 2021. For years, AI lived in two separate countries. One only saw pixels, shapes, 1,000 boxes. The other only read words, sentences, language. Clip didn't make either side smarter. It built a bridge. One shared space where a picture and its description are the same point, in the very same spot. In the instant that bridge existed, words could finally walk across and rearrange pixels. That's the arc this whole series has been climbing. Machines learning, one paper at a time, to see, to read, to think, to dream, and today, to connect the two. Every type a sentence, get a picture. Toy your family has giggled at is standing on the bridge built in this one paper. The eyes of AI and the language of AI, after all those years apart, finally learned to speak the same sentence. See you next paper.